Welcome to the lecture. We'll learn number systems and how computers represent numbers and other multimedia types. Specifically, there are many number systems, but we will study decimal, binary, and hexadecimal number systems because they are practical and most commonly used in computer science. Now, we will learn additions and subtraction for binary numbers, and then we learn how computers represent signed numbers and other media types such as text, images, videos, and audios. So let us get started. So first we'll start with number systems. The most commonly used number system is decimal systems, even though in the human development history there are many number systems available, but this one is the most commonly used. And computer science uses this one a lot. That's why we're going to study this. And this one is very simple, and it may seem to be trivial, but if you understand this, and of course you do, I just want to re-emphasize how this works, and we'll transfer it directly to binary system. It works the same way. So for decimal system, there are 10 decimal digits or 10 symbols to represent values, or they are the face values. So beside the face values, this decimal number systems is going to also have positional systems. It is positional system with power of 10 because there are 10 digits. So for the first columns, it's going to have the values of units or 10 power 0. For second column, it's going to have the values of 10 power 1. The third column going to be 10 power 2, and so on and so forth. So let us give an example. If you have a number 1, 2, and 3, then it's going to be expressed as 3 face values or 3 symbols like 1, 2, and 3 that we see from here. Then the actual value is going to be computed by timing their face values with their column values or their position values. So we're going to have 3 times 10 is power 0 is 3. 2 times 10 power 1 is actually 20. And 1 times 10 power 2 is actually 100. And when we add them up, it is actually number 1, 2, and 3, 123 that we often know. And once again, you may see this is somehow obvious. And why do we have to study this? Because our binary numbers that computer use gonna work in the same way. So computer work with binary numbers and they are only having 2 digits. You may say why? Because it's only have the 2 states of a bit when it is on or off. And the 2 symbols is going to be 0 and 1. And they are the face values, of course. And it's also a positional systems, but because there are only 2 symbols, so it's going to have the values of power of 2. Then the first column is going to have the values of 2 power 0, second column is 2 power 1, third column 2 power 2, and so on and so forth. For example, if we have 101 is going to have their face values in 3 columns like this, 1, 0, and 1. But to find its actual values, we need to take its face values and times it with the position values and add them up. So let's say we'll add times 1 with 2 power 0 is 1, 0 times 2 power 1 is 0, and 1 times 2 power 2 is 4. Then we add this up, it's going to produce 5. Then this 101 in binary is actually 5 in decimal. And we start feeling confusing, like if you see 101, does it mean 101 or it means binary string? So normally if we work with different number systems, in some case we'll just add the bases like this. So the Base number 2 over here means it's binary numbers, and base number 10 over here means it's decimal numbers. Then another very common base that computer system use is hexadecimal numbers. So it's going to be represented by, of course, 16 symbols with 10 digits plus 6 letters going from A, B, C, D, E, and F over here. Now, it again works in a very similar way. So the face values for A is 10, face value for B is 11, face value for C is 12, and so on and so forth. What does it mean is that if we see A, it means 10. Okay, but we use only one symbol to represent it, not two symbols. So let's just give an it is also a positional system, so it is also power of 16. And that's why for the first column, it's going to be 16 power 0, second column 16 power 1, third column 16 power 2, and so on and so forth. Now, let's say if we have an example which is 2ED, okay, and if this 2ED is going to have the face values in 3 columns or 3 positions like this, and it works in the same way. If we want to find it values, we want to times that face values with their positions values, and we're going to add them up, and we're going to get the actual values. So we times with this, and we're going to replace them with their face values of 2, 14, and 13 for the symbols. Then we'll get 512 over here, 224 over here, and 13 over there. And when we add them up, we're going to produce this 749. So 2ED means 749 in decimal. So again, we in many cases will add the subscripts. Okay. Now, why hexadecimal numbers? Because hexadecimal digit is a group of 4 bits. So it's going to have 4 binary digits over there. Why? Because computer work with only one digit, one bit, 2 digits for 1 bit that represent 0 and 1. But if we need to represent numbers in 0 and 1, 0 and 1, a lot of them, then it's going to be difficult for human to read. That's why we normally group 4 of them into one group and represent them as a hexadecimal number, so it's easier for human to read. Okay. And it's going to be less error prone. This one is another exercise for you to try out. You can stop here and try this. Let's say, please convert the following numbers in different bases into decimal numbers or base 10. So we'll have the first 2 in binary base, and the next 2 is hexadecimal base.